Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 11.1, Problem 12. This is Section 11.1, Problem 12. It says, use the given graph to solve the limit questions shown below. So we have a graph, and there are 12 different individual questions based on this graph. The first question, part A, says, find f of negative 3. So it's not even a limit. If you put in a negative 3, what do you get out? So if I put in a negative 3, the height at the graph is 0. Part B says, find the limit of the function as x approaches negative 3 from the negative side. So in other words, as you put in input values a tiny bit less than negative 3, or to the left of. So as I'm putting in input values just to the left of negative 3, what height am I approaching? Well, as I come into negative 3 as an x value, the y values are getting really close to 0. Part C says, find the limit of the function as x approaches negative 3 from the positive side. So from the right side, so as I'm approaching negative 3 from the value slightly larger than negative 3, the plus side of negative 3, my y values or outputs are also approaching 0. And then D says, find the limit of the function as x approaches negative 3, not from the positive and negative side, just what's the value of the limit as x approaches negative 3. So the height I'm getting closer to is 0. So that is the limit. And it's the value of the function and it's the value of the limit. Now next, part E, find f of 0. So if I put in a 0 for x, what's the y? Well, there is no y. It's an open circle. The graph actually does not pass through the 0, 0 point. So as I put in x values close to 0, I'm getting close to height of 0, but I can't actually put in a 0. There is no height there. So f of 0 is undefined. You do not have an output when you use an input of 0 at this point because of that open circle. Now the limit of f of x as x approaches 0 from the small side, the negative side, that height is 0. The value of the left-handed limit is 0. So as I have input values just to the left of x is 0, the height is coming closer, closer, closer to a height of 0. So that's 0. And then part G, find the limit of the function as x approaches 0 from the positive side. Well, from the positive side, or values slightly bigger, as I get closer and closer and closer to an x value of 0, the y is getting closer and closer and closer to a height of 0 also. And then H, what is the value of the limit as x approaches 0? Again, not positive or negative, just what's the value of the limit as x approaches 0. And the value of the limit is 0. It's coming to the same height on both sides. Now, part I, find f of 2. So if I go over to 2, the graph splits at 2. Notice it has a solid dot in line with the 2 and an open dot in line with the 2. So it's the solid dot that actually gives you an output. So if you go over 2, the output's minus 2. So f of 2 is negative 2. The limit of f of x as x approaches 2 from the small side, from the values just a little to the left of 2, the heights or y values you're getting out are getting close to a height of minus 2, going down, down, down. So the value of the left-handed limit, they would call it with the minus, the small side, as x approaches 2 is negative 2, this height or output. Now the value of the limit of f of x as x approaches 2 from the positive side, or right-handed limit. So as I put in values just to the right of 2 or just slightly larger than 2, the outputs or y's that I'm getting for it are getting close to a height of 1. And now, what's the limit as x approaches 2? Not from the small or large side, left or right side. Since it's going to 2 different heights, the limit does not exist. It has to come to the same height from both sides in order for the limit to exist like it did at 0. At 2, the two different heights, you would say the limit does not exist.